Hello. This will be a demonstration of proposition 35 from book 7 of Euclid's Elements, which says that if two numbers measure any number, their least common multiple will measure that same number. We're of course given two numbers a and b, and both a and b will measure some number cd. Furthermore, we're going to have the number e, and this number e will be the least common multiple of a and b. So a and b both measure e, and it is the least number which both of them measure. And what we want to prove from this is that this least common multiple, e, also measures our original number, cd. For if it does not, what we're going to be able to do is we're going to be able to subtract a multitude of e's from cd and leave some remainder which is less than e. And this is exactly what we're going to do. We're going to take all the e's to be found within cd. We're going to gather them all up, put them in the number df, and we'll have the number cf, which is the remainder of cd and df, and this number cf, this remainder cf, will be less than e. This is what we do in proposition 7.1, so if that process isn't clear, go check out that video. So, next, because a and b both measure e, right? Remember, we were given that e is the least common multiple of a and b, so a and b are both going to measure it. And we know that e measures df. We established that in our first step, remember? So by property of numbers, a and b are also both going to measure df. But we were given that a and b both measure cd. So a and b measure both cd and df. So by a property of numbers, it's also going to measure the remainder, of course, right? So think that 3 measures 18. 3 also measures 6, so 3 is going to measure 18 minus 6, which is 12. That's all that's going on here. So because a and b both measure cd and df, a and b are also going to measure cd minus df, which is the number cf. So what that tells us is cf is a common multiple of a and b. And remember in our first step, we said that cf is less than e. So we have a number cf, which is a common multiple of a and b, which is less than the least common multiple of a and b, which is just impossible. What we end up having to say is that this number e is both the least common multiple of a and b, and it's also not the least common multiple of a and b, which is just absurd. And so what we can conclude is that this least common multiple e does in fact measure cd, and this is precisely what we set out to prove, which means we are done with the proposition, therefore etc. QED. An example of this, what this would look like is, so 2 and 3 both measure 18. And what this proposition tells us is that their least common multiple will also measure 18. So what's the least common multiple of 2 and 3? Well, it's 6. So what this tells us is that 6 measures 18. And we can verify that this is true and see that this proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to proposition 7.36.